Welcome to Dr. Jarrett's Science Shenanigans Teacher Edition. I'm excited for you to be here with me today. I'm excited to share my knowledge of the grade 5 science standards, specifically what the students will need to know and will not need to know to pass their 5th grade science assessment. Do not forget to like, share, comment, and subscribe. Thank you again. I've been passionate about empowering educators in science education for many years. My dedication to science education also led to my dissertation, which focused on developing impactful lessons for science improvement. Since 2007, I've worked with over 75 schools across Florida, assisting in boosting grade 5 science scores. Together, we're making a difference in how young minds explore and engage with science. I'm so excited about you being here with me today. The benchmark we're focusing on today is SC.5.P.9.1. Investigate and describe that many physical and chemical changes are affected by temperature. This benchmark is also a third and a fourth grade benchmark, which is 3P9.1. Describe the changes water undergoes when it changes state through heating and cooling by using familiar scientific terms such as melting, freezing, boiling, evaporation, and condensation. So, the students would need to do a activity that includes those things. SC.4.P.9.1 identifies some familiar changes in materials that result in other materials with different characteristics, such as decaying animals, plant matter, burning, rusting, and cooking. So these three can be grouped together and could be taught over a couple of days. I would definitely group my 5P9.1 and 4P9.1 together, and talk about physical and chemical changes, and then the changes that decaying animals, plant matter, burning, rusting, and cooking, all of those would be my chemical changes. And so my physical change will be something where I'm changing something, but I'm not changing the what it originally is. So if I have a piece of paper towel and I just tear this piece of paper towel, it's still paper towel. But if I was to actually burn this piece of paper towel, is it now still paper towel? No, it's burned. And that is because the temperature of it got so hot that it now changed into ash. And so what I did for this is I did a like a display board, like a science fair board. And I at home in a safe environment, I burned paper, and then I took the ashes of that paper and I put it into a Ziploc bag and I labeled it. And then I had a piece of paper in a Ziploc bag and I labeled it. So now I have my physical change. It was just cut up pieces of paper, my physical change, and then I had a chemical change where it was the burned pieces of paper. Also, I had a apple that was decaying a little bit. And so I had an apple in a bag, and then I had my decaying apple. Also, rusting Brillo pads, or if you go to the Dollar Tree, sometimes they do have the steel wool, but a lot of times it's the Brillo pads. I would just take those and run them through water to get the soap out of them, and then leave it on the counter. By the next morning, I already have rust. And so I would put that in a Ziploc bag and then put a regular piece of steel wool or the Brillo pad in the Ziploc bag. So basically, I would have physical changes on one side of my board and chemical changes on the other side of the board so that the students can see the difference between the two. I would also have a piece of bread that I would put in a bag, and then I would make some toast and put that in a bag, so that the students can determine between the two. There is a YouTube video on my site for physical and chemical changes where I have lots of pictures and I show the kids and they have to determine if it's a physical change or a chemical change. I would show the students melting. I would show the students freezing, boiling. I would show them those things, but I would also have a thermometer to show them the temperatures of those things. When does something start melting? When does it start freezing? When does it start boiling? What is evaporation and what is condensation? And so I would depending on your school, make sure you get it cleared through your principal. I would have a hot plate and I would put the ice that is frozen in the hot plate, and the students, I would turn it on. The students would see the melting. Then they would see the boiling. Once the boiling happens, then you have the evaporation, and then you could also have them seeing the condensation. And so I don't really like doing condensation with boiling things because that means I have to have something on top of it. So I try to stay away from being around anything that gets hot with the students. So for condensation, I will actually take the another ice or a frozen bottle, and once it starts to melt, the condensation would also appear on the outside of the bottle without opening the bottle of water. Um, Lots and lots of pictures, diagrams. They gotta see this, they gotta touch this. Whenever you're dealing with physical science, this is where the kids' hands get dirty. Also, if you are doing oobleck, which is cornstarch and water. Oobleck is a physical change. It is not a chemical change. All they're doing is adding water to cornstarch, and they're making this wonderful substance that seems to be a liquid and a solid at the same time. It's amazing stuff that gets all over everything. But it's cornstarch. So if I left that cornstarch out, the water evaporates from it. I'm now left with cornstarch again. It's amazing. It's just wonderful. Same thing with sugar and the same thing with salt. Um, that would happen as well. Um, I you could even make s'mores. This would be an awesome time to make s'mores with the students. Where they would actually be able to eat what they've come up with. They're eating science. It's amazing. So that would be something that I might want to do with my students as well. Um, if you watched the video already with the space when we did moon phases, hey, they had Oreos, so this will be a perfect time to have some s'mores. Put it in a Ziploc bag and send it home so they can eat it at the house with the family and get hyper there if you don't want them eating it at school. But as many hands-on opportunities you can do with the students. Now, there's a little side to that. If I walk into your classroom and I ask the students, what are you working on? They should not say making s'mores. They should say that we are investigating physical and chemical changes. Because when I crack or break apart the graham cracker, that is a physical change. Now, when I am burning my marshmallow, that is a chemical change. And when I am warming up my piece of chocolate, that is still a physical change because we didn't change it from being chocolate. Once it cools back down, it's still going to be a chocolate. So That's where the students could have a debate if it's a physical or chemical change. Um, and so, boom, there you go. That's perfect. The kids are going to say, we are investigating, describing physical and chemical changes. At the same time, we're going to eat this food. It's going to be delicious. So I hope this has helped with physical and chemical changes, and also 3P9.1 describe the changes that goes that water undergoes when it is changed through states. So solids, liquids, gases, which is the melting, the freezing, the boiling, evaporation, and condensation. And the 4P9.1, which really deals with our chemical changes more. I hope you have enjoyed this. Oh, no more particles. Remember, we talked about that with 5P8.1. We're not doing particles, so we shouldn't be having conversations about particles, emotions when things change state. They just don't add that to what you already have to teach them. They'll learn that in high school, I promise you. Middle school. They'll learn in middle school. I just want you all to have an amazing day. Thank you so much again for watching this session. The book, Unveiling the Power of Impactful Science Instruction, is available on Amazon, and it is a glimpse into my dissertation investigating the improvement in science achievement among fifth grade science students when using the instructional model.